Good evening to all of you. Welcome you guys. Welcome you all. How you are doing, everybody? Welcome you guys. Welcome you all. So welcome to this Unacademy. Now and we are going to discuss about the physics concepts in the ATC Airport Authority of India ATC. And in this, we are planning to discuss the concepts related to the physics concept. And today's lectures, I am planning to discuss waves topics I'm planning to discuss. Chalo, let's start our discussions now. And so here all of you try to follow this series of lectures so that you have better understanding. As you might be seeing in the ATC papers, and those papers are giving the 30 questions from physics and 30 questions from mathematics. And when you are coming to this physics, the topics what they used to give is completely 11th and 12th physics topic questions they are asking. All the questions they are asking, what tell me? 11th and 12th physics questions. Try to follow this series of lectures. You will have better knowledge. I will try to discuss each and every concept briefly according to the level of Airport Authority of India ATC. Okay, and so in previously we have discussed some concept, and today's class we are planning to discuss the waves in the sense, and all type of waves we have. The different type of waves are there: longitudinal waves, transverse waves. All these waves we are going to discuss in detailed manner. And level of the questions are very basic level questions, but you need to have some idea about those questions. And before starting our lecture, and you can have a look at now briefly, right? The recently this Unacademy has given this great offers are waiting. You can have a look at now. And when we have taken this as a 9 month subscriptions, आपको additionally 1 month मिलेगा. This is just 8,999 only. You have taken 12 months of subscription, आपको 2 महीने extra मिलेगा. That is so 9,999 only. To avail these opportunities, you can use the code of BV Reddy. Use the code of BV Reddy, then only this offer it can be applicable. Use the code of BV Reddy to avail the great learning experience and from the top educators live classes. India's top educators classes you can able to access. Multiple batches are there. If you are missing any of the topic in any course, so you can able to watch in some other batches, you can able to watch it. And you can have a complete series भी आपको मिलेगा, and practice sessions, practice questions भी आपको मिलेगा, and iconic वाला को physical notes भी मिलेगा. एंड 1-to-1 mentorship भी होगा आइकॉनिक में. The student who are interested for an academy subscription and utilize the opportunity before it going to expire, and the offer which is extended up to the 10th May, that is tomorrow, is the last day to avail these opportunities. Don't miss and try to enroll it as early as possible. You can have a look at now here. And the rankers, the student who got this in GATE 2025 rankers, up to 1 to 100 fellows will get 80% of discount milega, and up to 500 will get 70% of discount, up to 1000 will get a 65% of discount. And these are the ATC batches we have started. Of course, I started in plus course, I started this ATC batch only, and electromagnetic waves we have started, the magnetic fields, and you can enroll for this course and you can follow these courses. And you can see now here, so ATC course, that is only 3,999 only. Apply this thing before it going to expire, and use a code of BV Reddy to avail these great opportunities. And the other new batches we are starting, you can have a look at now here. In electronics and communications, the other top educators of Unacademy team, and we are starting a new subject, maths. We are starting. You can have a look at now for 2026 as well as 2027 also. And the test series, the student has enrolled for the Unacademy subscription, आपको पूरा टेस्ट सीरीज फ्री में मिलेगा. The test series you can have a look at now here. Part test, we have number of tests are 29, and so here part syllabus but mixture of subjects, that is what tell me now 10, and advanced test, that is 10, part syllabus multiple subjects 6, and mock test, full length mock test, that is 10, and PYQs भी आपको टेस्ट सीरीज जैसा मिलेगा, that is 12 मिलेगा. You can have a look at now total number of questions you are can able to practice freely, 2645 questions. By solving these many questions, you will be become master in all the topics. Okay. And the plus subscription and iconic subscription, the plus students will get the live classes from the top educators, doubt solving sessions, and structured courses, live quizzes, unlimited access. And the iconic fellows will get additional benefits of, that is what tell me now here, physical notes bhi milega, and they will get it as what tell me, one mentorship bhi milega. And these are the additional benefits of plus and iconic. And so what you need to do here, mentorship ke liye you need to book a slot and book a session and pick the time according to your convenience, how much the slot time you want, and the timing also you need to select. Then yes, your mentorship program is created. You can directly communicate with the editor, avail this to know the how to access, how to plan your career, to utilize this Unacademy the best way to have a great learning experience from the top educators. So yes, let's crack it. Chalo, these are the rankers you can see now for GATE 2025 May, and how many ranks are counting. You can have a look at now. These are the top 20 में इतना ranks मिला. You can have a look at. चलो, आज का सेशन हम शुरू करेगा. राइट. right? Now, so आज का फिजिक्स का टॉपिक हम डिस्कस करने वाला दैट इज वेव्स एंड we are discussing the topic which is waves. Now, what is a wave? First of all, wave means what? Tell me. Wave is nothing but a periodic disturbance. Periodic disturbance that propagates in space, transports energy and momentum energy and momentum without transferring of matter. Without transferring of matter. Wave, wave is nothing but what? Tell me now here, a periodic disturbance. Wave is nothing but a periodic disturbance, a periodic disturbance, right? And that propagates in space, transports energy and momentum without transferring of matter is called as a wave. And the different type of waves we have. So one is we should discuss mostly the different type of waves. One is called as a transverse wave. Transverse wave. And the second one is a longitudinal waves. Let us discuss about the transverse wave first. Transverse wave means what? Tell me now here. If the particles vibrate, if the particles vibrate, if the particles vibrate, vibrates perpendicular, perpendicular to the direction of propagation. Direction of propagation, then those waves, those waves are called as transverse waves. If the vibration of the particle is perpendicular, then we can call them as a transverse wave. The second category, which is a longitudinal waves. Longitudinal waves. Longitudinal waves means if the vibration is tangential to the direction of propagation, then we can call them as a longitudinal waves. These are not visible, I think so. Low. No. The block is suitable, I think so. No? Is it visible? If the particles vibrate parallel, or we can say tangential. Tangential to the visible now this color. Not I will go for black only. Direction of propagation. Then those waves are called longitudinal waves. Longitudinal waves. Right. Next. General form of wave equation. Wave equation. So here the general form of wave equation. The general form of wave equation is wave equation. So which is how the form y is given as it can be some function of ax plus or minus pt. This is the general form of wave equation. General form of wave equation, which is equal to y equal to ax plus or minus pt. We are talking about the first. Yes. Tushar, we are talking about first this one waves. Thereafter we'll discuss the next chapter we'll discuss. Okay, this waves, and next we'll talk about the optics. These will have a very good weightage, as I have seen the previous questions, previous papers. Waves and this optics will have a very good number of weightage. And today we'll finish the waves, and tomorrow and day after tomorrow, 2 days we'll do the optics will do. Okay, same timing, 9 p.m. only. This is the general form of wave equations. So where f means some function, f means some function. Now you can see now here some constant into x power must be a 1 only, and t power must be 1 only. Then only that is called as a wave. Then only that is called as a wave. If it is a power of x or power of t something else, that is more than 1 or less than 1. So let us say in that cases, that is not a wave. That is not called as a traveling wave. Right. Now, in these cases, whenever they given, so example we can see now here. Examples of waves, you tell me now if I say this as y is equal to, let us say here, sine of, it is of the form that is kx minus omega t. Is it is a wave equation or not? You can see now here, either plus or minus can be anything. So here the sine is a function, x power is 1 and t power is 1. So that's why this is a wave equation. Now if they given something else, let us say here, now, so let us say here ax plus bt whole square. Is this the wave equation or not? We need to see here these powers we have to see now here. This is also one, that is also wave equation. Okay, next if we have like this, let us say here cos of, let us say they given omega t minus kx. Is it is a wave equation? Yes. So x power, y power, t power is 1. Now if they given the y which is equal to something, let us say here, that is a into root x plus bt. Is it is a wave equation? Here this x power is how much? 1 by 2. X power is 1 by 2. So here this is not a wave equation. This is not a wave equation. Okay. Wave equation means here that should be in this form. X power is 1 and y power, t power is also 1 only. Then only that is a wave equation. Now if they given like this, then velocity of wave velocity formula here, which is equal to minus of, which is equal to coefficient of t by coefficient of x. Velocity formula, that is what will be coefficient of t by coefficient of x. If the velocity of wave, if it is positive, if we got positive, that is the indication that wave propagating positive x direction. Positive x directions. And if velocity of wave which is negative, that means what terminal here? Wave propagating wave propagating negative x direction. So based upon the velocity, we can decide which direction the wave is propagating with what velocity. The velocity of wave is given by what, tell me? Velocity of wave is given as coefficient of t by coefficient of x. All of you tell me. Coefficient of t by coefficient of x. Right. Yeah, you tell me now here. The wave equation which is given as y is equal to a sine. So this is 10 pi t minus 2x. Can you tell me now what is the velocity of wave? What is the velocity of wave here? The velocity of wave which is given as what, tell me now, minus of what, tell me, coefficient of t by coefficient of x. So this based upon the velocity, they given one problem also. Coefficient of t by coefficient of x. Coefficient of x. The velocity of wave which is equal to minus of, you tell me now, coefficient of t which is equal to what, tell me here, this is 100 pi by coefficient of x is minus 2 now. So what will get the velocity of wave, you tell me, which is given as what, tell me now here, that is a plus 50 pi na. How much it is? 50 pi. So this velocity of wave which is positive, that means the wave is propagating along positive x direction with a velocity of 50 pi. Okay. Now you tell me now here, if they given the wave y is equal to 10 sine of so it is a 4x plus 100t. Tell me the velocity of wave in this case. The velocity of wave which is equal to what we can say here, minus of coefficient of x by coefficient of t. Coefficient of t is how much? 400 by coefficient of x is what, tell me now, 4 plus 4 now. So how much will come here? This is 250 by 2. So it which is equal to 125 minus 125 now. Minus 125. That negative sign indicate what, tell me now here? That means what, tell me, in this case, wave propagating along negative x direction here. Wave propagating along negative x direction. Okay. Now this is the velocity we have seen if they given a wave equations. Now in general form, so here, so generally the displacement of a particle displacement of particle displacement of a particle which is given as y of x comma t if I say, which is of the form it is a sine, that is omega t minus kx. This is the general displacement of a particle. The displacement of a particle. Okay. Now in this case, what we can say now, velocity of wave. Here wave velocity, if you ask, so it will be come to be a what, tell me? Velocity of wave which is equal to coefficient of t by coefficient of k, that is minus, this is the velocity of wave na? Velocity of wave. Next. And time period means what, tell me? We know the formula basically, time period t which is equal to what, tell me now? 2 pi by omega. Time period is what? 2 pi by omega, where this k which is called as a wave number or phase constant, k is called as a phase constant, that is k which is equal to 2 pi by lambda. So if there k is the phase constant which is given as 2 pi by lambda. Time period which is also equal to 1 by frequency na? Time period which is also equal to 1 by frequency. The important concept briefly, whichever the topics related to the ATC, according to the ATC, we are discussing the topics. Right. Next one. The relation between phase difference and path difference. This is another important formula. Look at the relation between phase difference and path difference. And so this is delta phi, we are calling it as a phase difference. Delta phi is a phase difference. Delta x is a path difference. Delta x is a path difference. Then the relation between these two, which is given as delta phi, which is equal to 2 pi by lambda into delta x. Delta phi which is equal to 2 pi by lambda into delta x, where delta phi is the phase difference, delta x is the path difference. Delta phi which is equal to 2 pi by lambda into path difference. This is one of the very important formula, and try to remember this one. Okay. Next, velocity of wave in string. Velocity of the wave in a string. How the velocity is. Means what we did here. Consider, have taken some string which is tightly fixed to the one end. And at other end, we have connected some mass we have connected. Now, I folded this thing here, applied some force and released it. Then, the weight of this block, which is vertically downwards, and there is some tension developed in the string now. The tension developed in the string is T. And assume that here I am calling this the weight, which I am calling this as capital M. Mass of this block, which is equal to some capital M tension. And here the length of the string is L, and M is a mass of the string. Then here T is the tension in the string. Tension in the string. M is the mass. M is a mass of string, not the block. And L is the length of string. L is length of string. Then, so velocity of wave. Velocity of wave is given as velocity formula, that is given as square root of T by mu, where this mu is called as linear mass density. Linear mass density. And this mu, which is given as mass of string by length of string. Mass of string by length of string. So the mu, which is given as what we can say here, M by L. That mu is equal to M by L. Okay. Completed. Next. The next one. Superposition. Superposition of waves. Superposition of waves means what? Tell me now. If the two waves are overlapping, that overlapping is called as a superpositions. The overlapping of two waves. Waves is called as superposition. Now, due to the superpositions, the two waves will interfere, will have a maxima and minimas. Then we have two types of interference. We have one is called as a constructive interference. Constructive interference. One is called as constructive interference. Constructive interference means the two overlapping waves should have a same phase difference. If the two overlapping waves will have a same phase difference, means consider we have a two waves are there. Let us say y1 is equal to, we can call it as a1 into sine of omega t, and y2 which is equal to what? Tell me now, a2 into sine of omega t plus some phi. There is a phase difference with the two waves we have. Then if the two waves are superimposed, we have a maxima, minimas will be formed. That maxima condition is what? Tell me now here. If phase difference for the constructive interference, phase difference is delta phi, that must be in the form of what? Tell me now, 2n pi. Phase difference is how much? 2n pi. And the path difference is delta x, which is equal to n lambda. Path difference is n lambda. In this scenario, we have a amplitude is maximum. Then maximum amplitude, which is given as what? Tell me now, a1 plus a2. Maximum amplitude is given as a1 plus a2. This is called as a constructive interference. Right. Now, when you are coming to the destructive interference, the second one is a called as what? Tell me now, destructive interference. Which color is writing properly here? If this is visible properly. Destructive interference. And for the destructive interference, the conditions are what you tell me? That is phase difference. Phase difference delta phi. No, phase difference delta phi, which is equal to what? Tell me. 2n minus 1 into pi. That is odd multiples. And the path difference is delta x, which is equal to n lambda by 2. And in this case, we have a minimum amplitude. That amplitude is given as what? Tell me. A1 minus A2. A1 minus A2. The difference between the two amplitudes will come in this case. Okay. Constructive interference means phase difference is 2n pi, path difference is n lambda, and the amplitude is maximum. Destructive means odd multiples of pi, phase difference is n lambda by 2, and amplitude is minimum A1 minus A2. Okay. Next. Next one. Level. Sound level. So sound level, basically humans can hear. How much the sound level can able to hear? Intensity. Intensity of sound ranging from 10 power minus 12 watt per meter square to 1 watt per meter square. This is the range of sound level humans can able to hear. This is the range of sound level. That is 10 power minus 12 to 1 watt per meter square. Right. And this 10 power minus 12, this is the minimum sound we can able to hear. And this is called as a threshold hearing. That will denote this as a I0. I0 is called as a, that is a minimum intensity that humans can able to hear. That is called as a threshold hearing. Threshold hearing. And the threshold hearing is how much? That is a minimum intensity humans can able to hear, that is 10 power minus 12 watt per meter square. Threshold hearing. And sound level, generally we used to express in the decibels we express. So that is sound level beta, and which is given as 10 logarithm of what? Tell me. Intensity by threshold hearing. This is the sound level. 10 log I by I0 is called as a sound level. Okay. Copy it now. The next one. Next one. Doppler's effect. Doppler's effect. The Doppler's effect means the apparent change in frequency of sound relative motion between source and observer is called Doppler's. What about the Doppler's effect? Means, and for example, let us say here this is the source and here is the observer. Now you tell me now here, let us say if the observer is moving like this, then what happened to sound level? Intensity of sound, how it will appear now, increases or decreases? Sound level decreases, isn't it? And when the person is moving these directions towards, sound level intensity increases now. Actually, the intensity, the increase or decrease, that is because of variation of frequency. The frequency variation, apparent change in frequency of sound, whenever there is a relative motion between the source or observer. If the source is moving or observer is moving, and there is a frequency heard by the observer may not be same as the actual frequency. There is some difference is there. That frequency is called it as, that is called as a apparent frequency. This is which is called as a apparent frequency. That is, that effect is called as a Doppler's effect. This phenomenon is called as what? Tell me. Doppler's effect. This phenomenon which is called as a Doppler's effect. Okay. The variation of intensity of frequency. That apparent frequency formula, apparent frequency, that is FA, which is given as, this is the velocity of sound with respect to observer by velocity of sound with respect to source into actual frequency. This is the formula of the apparent frequency. The frequency heard by the observer may increase, may decrease. That depends upon what? Tell me. Relative motion between the source and the observer. Okay. Okay, done. Right. So if you have to see some problems now here, uh, take this one here. A plane progressive wave is given by y equal to 2 cos 2 pi into 330t minus x. The frequency of wave is, right. And look at now, the given expression y is given as what I mean 2 into cos of 2 pi. They took the common, so take 2 inside. So this is 2 pi into 330 pi into 330, sorry, 330 t minus what element of 2x. Now this term is called as omega. Na? How much is omega value? 2 pi into 330. As we know, omega equal to 2 pi f is equal to 2 pi into 330. From this, frequency f is equal to how much, you tell me now? 330 Hz. Okay. Next one. A steel wire with mass per unit length. Mass per unit length 7 into 10 power minus 3 kg per meter is under tension of 70 newtons. The speed of transverse wave is So you tell me now what they given here. They given mass per unit length, that is nothing but mass density, linear mass density mu, which is given as 7 into 10 power minus 3 kg per meter, and the tension which is given as what, 70 newtons. Now what is the speed of transverse wave? What is the velocity of transverse wave? V, which is given as what, tell me, square root of t by mu, and which is given as square root of t value 70 by 7 into 10 power minus 3. So that is V will come to be a what, tell me now here? 70 into 10 power minus 3 will become plus 3 by 7. So this value is how much now here? So this is 10 into 10, 3 na 10 power 3 by 1. So this is what, tell me now here? 100. That is meters per second. Isn't it? Okay, right. Fine. Yeah, that's it for today's sessions. And we'll meet tomorrow. And tomorrow we'll discuss about the optics. We'll see. First, we'll see the ray optics. Thereafter, we'll see the wave optics. Okay, then. See you. Bye bye. Good night.